There are several methods for flood protection that do not involve elevating buildings. With these non-elevation methods, there are several water challenges that are not a problem for elevated buildings. These methods include constructing barriers, such as levees or flood walls, around the building or temporary versions of those. Applying sealant or waterproof film directly to the building to make it watertight, or reducing the damages by elevating appliances and utilities and using building materials that aren't damaged when they get wet. With any non-elevation method, backflow through drains must be stopped. Backflow through sewer lines is the most important. This is because sewer water is highly contaminated. If you do nothing else to reduce flood damage in your home, you should stop sewer backflow. Fortunately, it's easy and inexpensive to correct this problem. The other problems associated with barrier-type flood control systems have to do with rain that falls inside the flood wall, levee, or temporary barrier, water that seeps under the barrier through the soil, and water that leaks through the barrier, sealant, or closures. Let's tackle sewer backflow first. Toilets, bathtubs, and sinks all drain to a common sewer line. This line, which is usually 4-inch PVC, carries sewage away from your house for treatment. When floodwater gets into the system, sewage and floodwater flow backward through the line and into your home. The best way to stop backflow into your home is to install a permanent valve in your common sewer line between your house and the sewer cleanout. There are several choices for valves. They should all provide minimal resistance to flow away from the home in non-flood conditions. The simple flap valve closes automatically. It is installed so sewage water leaving the house pushes it open. When the flow tries to reverse, the valve closes. The flap valve is one of the least expensive backflow valves and the most prone to failure. Trash that sticks on the valve gasket can prevent the valve from closing completely and cause it to leak. Another option is a valve that is closed manually. Manually operated valves provide more positive closure but won't work unless somebody is there to close them. A ball valve is open when the handle is in line with the drain pipe. When the handle is perpendicular to the pipe, the valve is closed. A quarter turn closes the valve. This valve, made of PVC, costs about twice as much as a flap valve. Another sturdier valve is this brass gate valve. It opens and closes with the same turning action as an outdoor faucet. This valve can overcome most debris encountered in the line. It costs about 3 times as much as a simple flap valve. 2 automatic valves have been introduced recently. One is a flap valve with a floating trigger. Its advantage over the simple flap valve is that it is normally open and closes only during a flood, so it is less likely to catch debris on the seal. This valve comes equipped with a bypass and a pump, so sewer water can get out even when floodwater can't get in. Valves of this size are sold for homeowner use. Larger versions are sold for use in municipal sewer systems and stormwater drainage systems. Another recent innovation is a gate valve that closes when the sewer system floods. It presents a clear path when open and closes with a positive seal, so you don't have to be there to close it. Automated valve systems are more expensive than manual valves. Installation of any of these valves is equally difficult. You'll need to dig to expose several feet of sewer line. Depending on the valve you chose, you may need to add short pieces of pipe to the valve. Remove a section of sewer line just long enough for the valve to fit. Connect the valve to the sewer line with couplings. The valves we've been discussing, the flap valve, the ball valve, and the gate valve, come in different sizes and can be used to prevent backflow through any drain tube, such as those installed at the base of a levee or flood wall. There are other ways to stop the flow in these lines, by capping the tube or using a gripper plug. Gripper plugs, like valves, come in a variety of sizes. This plug fits in a bathtub drain. This one is the right size for most toilet drains. Remember to shut off the water before removing the toilet to plug the line. As long as there is more water outside your flood wall, levee, or building than there is inside, water will be trying to push through the soil and force its way through the barrier. Extending a barrier deep into the ground will reduce seepage. With careful design, construction, and maintenance, the amount of water that must be pumped can be kept to a minimum. In most cases, the greatest source of water will be rain. The biggest rain collector you have inside the barrier may be your roof. Build the levee or flood wall so rain that falls on your roof drains outside the barrier, eliminating the need to pump it out. This home shows that being done two ways. On the end of the house, the flood wall is under the roof overhang, so rain falls off the roof to the water side of the flood wall. Where rain from the roof would fall inside the flood wall, gutters collect the rain and deliver it to downspouts that dump it over the wall. Be sure the gutters can handle the maximum anticipated rainfall or provide additional pump capacity to handle the overflow. A pump is needed for rain that falls between the barrier and the roof, and for water that leaks and seeps in. The water must drain to a collection area to be pumped out before it rises to a level that will do damage. This collection area is called a sump. These are some pumps you might see at a retailer or in a catalog. When shopping for a pump, tell the salesman exactly what you want the pump to do. There will be a pump to fit your specific needs. Choose a pump that is capable of pumping the water out at least as fast as it enters. Be sure it can pump this amount through the hose and against the required head. Head is the difference between the surface of the water you're pumping and the pump outlet. Usually, a high-volume, low-head pump is best suited to this task. A self-priming pump is recommended. Another thing to consider is whether the pump will handle small amounts of debris. If you choose an electric pump, be prepared for the electricity to go off. You'll need an electric generator. One generator can run several pumps and power household appliances. If you're interested in automating the pump system, remember this is easier to do with electric pumps. Gas-powered pumps and generators should never be run indoors. Carbon monoxide poisoning can result. Opening doors and windows is not adequate protection. Even with careful planning, construction, and maintenance, you should still expect some water to penetrate the barrier. You can prevent this from becoming a problem if you're prepared to pump.